Welcome to the third and final video on the Spring Common Assessment Review Packet for Precalculus, the free response problem. So in the last video I did not mention how the points were awarded in Part E. I'll do that right now. So you would have earned the first point if you set R of t equal to 0, just if you, or I'm sorry, not equal to 0, equal to 2. Sorry about that. If you set R of t equal to 2, you earned that first point on this problem. The second point comes down here if you got both values. And then the third point comes from the interval. So that was 3 points on that problem right there. Okay. The final problem is talking about a different tank, and we have this sinusoid. We just have to come up with a function that's going to model this sinusoid that we are given. Well, we want to break this down a little bit. I see it's starting going down, coming up, and then it finishes a period, and it looks like it finishes a period right about here, which would be at 12, which means our period, then one period is 12 units long here, okay? Well, that's going to be useful for sure. Well, I put the starting and ending points right here along our midline, which is at 5, 6, 7, right there. And then if you notice, our max is at 12, and our minimum is at 2. Well, that's going to be kind of useful to us. Notice we go through the midline right in the middle there of our period, which would be right at 6. Okay, cool. So we want to talk about the amplitude as well. Well, the amplitude is this distance between the max and the midline. Okay, and that amplitude we can just count 1, 2, 3, 4, 5. Alright, and we've got basically everything that we can now from the picture. We've annotated this picture fully. Now we got to just get the equation, alright? And from the first video, we had this kind of basic equation. It goes something like y, or in our case, f of x is going to be equal to, alright, it was a times a cosine or a sine function. Well, if this starts at a midline and goes to a midline, then that's going to be a sine function, not a cosine function. And we're talking about b times, alright, x minus c plus d. And just remembering our annotations from before, a is related to the amplitude, but it's really the absolute value of a. We got to figure out what the sign should be on a for sure, but it's related to the amplitude by the absolute value. We also have that 2 pi over b is equal to the period of our function, so that's how we're going to get our b value. The c is the phase shift, which is how far left or right we're going to translate it, and then d is the vertical shift, which we're talking about the midline there. Okay, how far up or down have we moved this from the x-axis? Okay, so let's just start plugging in what we know. Well, we know the amplitude is 5, so we know it's got to be a 5 right here, but we just got to figure out if it's a plus 5 or a minus 5. Well, remembering what the basic sine wave looks like, it starts at the origin, goes up to a max, comes down to a minimum. That's what sine x looks like for its first cycle right there. Well, if it starts up and ours started going down, it should have been a negative on that 5. We've reflected that sine x over the x-axis right there. Let's get our b value. Well, we know the period is 12. Okay. Well, we know that 2 pi over b is equal to the period. Well, that means that we need to take our 2 pi and divide it by 12 in order to get our b value. Well, 2 pi over 12, that's the same thing as pi divided by 6. And then we've got x minus our c value. Well, what's the c value here? Have I shifted my sine function left or right any? Well, here's the y-axis, and I'm going right there with a start of my, so that c value is 0, okay? The d value, that's how far up or down I've gone. My midline, well, my midline is 7, so I get the final answer right there. We could simplify this down a little bit. -5 sine of pi over 6 times x plus 7. That's what f of x is equal to. So how are points awarded on this one? Well, you get your first point if you had at least 2 of your A value, your B value, and your D values correct. And you'd get your second point if you had all 3 correct. Okay. So it is worth a total of 2 points. Now, notice this is not the only way that you could have described this function. You could have described it in many, many, many other ways. Using a phase shift. If you had a non-zero phase shift, you could have talked about this as a regular sine function, but I shifted it over a little bit instead, and that's why it started as going down. And many of those other ways could have earned you points as well. All right, so realize if you had something that was equivalent to this, then you could still be earning points, but I would say out of 50 students, 49 who get this problem correct probably would come up with this answer. All right? Well, have a wonderful night, everybody.